Hey everyone, I'm David Room. Got some interesting stuff tonight. Going to be working on some 3D mesh processing, kind of general tools for working with manifold, watertight triangle meshes. And then we're going to zoom back out um, and look at some progress that I've made on high detail spacecraft and game spacecraft and fix a few problems that have arisen as I've been doing some tweaking and refactoring over the past couple weeks. So I'm just tweeting out here that I'm live, and then once I make sure that's gone out, we'll get started. So I'm gonna share my screen here in just a second, but I ran into kind of a nasty bug the other night. I've been working on this kind of high detail modeling and adding interesting greebles and details to my spacecraft models. And for those of you who might be new and don't know too much about my project, I'm building spacecraft models for a game that I'm developing and also for 3D art that I'm working on. And I have kind of a unique workflow where I actually do all of the modeling using the Python programming language. So rather than clicking around in Blender to make models and then maybe using some code to, do different things, I'm actually starting from Python code, not even code that's running inside Blender, but just Python code. And then from there, bringing things into Blender or into a particular game engine, and going from there. And the idea is to be able to have this kind of set of models and assets and things that I'm creating and managing with Python code and able to reuse in interesting ways. And I might get into some of that because some of this work that I've been doing is towards kind of a new target, if you will, for this stuff. So let's get right into it here. So I ran into this issue the other night. I working on a high detail model of a ship. It's a Corvette style spacecraft called the Scioto, and it has windows around the top part of it, and the window code was a little bit outdated. It needed to be updated to make the meshes watertight so I could do these Boolean operations. I've kind of brought Booleans back into my workflow because this new Boolean library called Manifold is really fast, and things that used to take 30 seconds or a minute now just take a few seconds. So Booleans got a lot more useful. And I kept running into this goofy issue. So I'll show you kind of what happened. So we'll run it without the bug first. You can kind of see what it does. And then I left the code here that causes the bug in, so we can see it. So I'm creating these panels and then adding these windows to the panels. Specifically, I was running into this problem with this kind of corner shaped panel that has a couple of windows on it, and everything is working here now. And just get through this. So here's kind of the finished model before I'm about to add some detail. So I'm at a step here called device greebles, where there's different devices like these shield generators and thrusters and things, and you can see that there's like this geometry around them, and that's going to become a cutter for a Boolean operation that's going to make a sort of panel indentation around those devices. You can see that more clearly here, and then the actual result looks like this. You can see how fast it ran. Sorry for the flying the view around a little bit. Let's see what my controls are for zooming. Sorry, just one second. Let's see here. Zoom is Control Shift left. Drag. It's not doing it for me. Oh, there it is. Okay. I've got some weird key mappings going on, I think. Yeah. Okay, but yeah, you can see the greebles, or the sort of indentations around these devices or greebles that kind of add more detail, kind of make things seem like they're not just stuck on there, but have sort of a place there. This is another ship. Everything generates really fast, and we can see the result here in Blender. So what was going wrong? Well, what was going wrong is when you do Boolean operations, you need to have meshes that are watertight, which means that they have certain nice properties. So they're enclosed, they don't have extra edges or holes, and then you also don't have certain sort of degenerate situations. And part of what was making me bump my head up against the wall with this was that it was sort of another non-obvious degenerate situation that was going on, and that's what we're going to build some tools to find. So Doug Wise says, I like the greebles on the panel edges, very subtle. Yeah, thanks. Part of what I'm going for is like I have kind of a knee-jerk reaction against adding details for the sake of detail. At the same time, I know my art needs more detail to sort of look sort of at the level that I want it to have. And adding stuff like this is kind of a no-brainer in terms of adding detail that, means something. Like, it makes sense that there would be panel cutouts or impressions or things around devices, but it also definitely adds interest, and it makes things look a little bit more professional and correct. Okay, so what was the problem? So the problem was in refactoring some of this code. There's a part here where I'm building these windows, and basically I'm slicing the mesh and then turning each slice into this indented window. And I have better ways of doing this now that I probably would use if I was rewriting this code again, but I wanted to make use of what I already had, right? And what I had forgotten was I had sort of not done this correctly. So I was actually, so this is correct, but what I had is I hadn't gotten rid of this extra loop here. And I'm sort of improperly reusing an iterator variable here. So I ended up concatenating together this duplicate of the mesh that I wanted to add. And this really throws things for a loop. And let me show you what happens. So, and it's very hard to see in the visualizer what's going on. So what happens here is, well, here, this was an assertion that actually finds it, which we're going to refactor. But what happens here is that when you go to do the Boolean cutting, adding this detail, you get the error, but you can't really see that there's a problem here. It's not obvious that there's a problem. You don't see any like reversed faces. You don't see any edges that are out of whack. But what happens is, and I triggered a case here because my code identifies that the mesh is not watertight. But then it's kind of not clear what's going on. So let me see if I scroll back here. Okay. Let's see here. Yeah, so yeah, okay. So yeah. So this is the problem. So we've identified that it's not watertight. But there are no boundaries. So the most obvious way that you could tell if a mesh was watertight is does it have any boundaries, right? A boundary being a set of edges where each edge only is connected to one triangle, right? So in a triangle mesh, if it's completely enclosed and there aren't any holes in it, you won't have any edges that are only connected to one triangle. Well, so it's got these boundaries, but then at the same time, we don't see, there's no obvious holes or anything. So like, what's going on? And then the confusing thing is that I had some other tools here where let's actually just comment this out. So when we find that it's not watertight here, and I'm going to comment out some of this other visualization stuff. Can get rid of this stuff here. So I already had a function that kind of tried to help sniff out what these issues were. And it's called info. And what info does is it finds the boundaries. That wasn't solving it. There's also a let's see here, where was the repair? Oh yeah, I know what it was. So let's see, where was that? Is it repair? Oh, I know what it was. Okay, so it was this function. So another way you can kind of tell if there's problems that are going to get in the way of Boolean operations is splitting the graph into different connected components. So if it's a manifold mesh, it should all be one connected component, right? You shouldn't have a chunk here and then a chunk there. Well, issue that I was running into was that I had this function which kind of analyzes potential issues with meshes being watertight via connected components, where I split it into components and then look at whether each piece is watertight. And this is the thing that stumped me, right? So I have this mesh that sort of appears to be watertight. I don't see any obvious like degenerate stuff going on. But then when I analyze it by splitting into components, it has only one component. But when you take that one component, then you end up with a piece that has additional boundaries. And I just couldn't wrap my head around what was going on. Well, here's what's going on. So I had these duplicate window pieces, right? So when you check for boundaries, and the way I'm checking for boundaries is, are there edges that have only one face? There's no edges that have only one face, but there are edges that have more than two faces. That's wrong. When you select by connected components, my method for selecting a component says there's only one component, but the component that it selects ends up tossing out those pieces that are connected by more than one edge, right? So when you do the selecting the connected components, you end up with the windows disappearing, and then you have these boundaries. So the problem isn't that we can't detect whether things are watertight. We have tri-mesh functionality that makes it straightforward to detect whether something is watertight, but it doesn't do the best job of showing why it's not watertight. And this thing really failed in this kind of pathological situation to surface what was actually going on. So I'm gonna write something new, and I implemented something last night that does this. So I'm gonna throw in some music, and I'm going to bring that functionality into a function here and kind of integrate it with the diff operation that I have, and try to add some better error messages. So hopefully, with the same issue, we get a much nicer error message that actually shows properly what's going on. So I'm gonna get into that. Let's get our trusty old music going here. So, and the if we look at this, the is watertight function, to be honest, I'm not really sure how it works. It's looking like it's checking whether every edge is shared by an even number of faces. I think we don't care if it's even. We just want it. We want to know that everything only has, like, everything only has 2. So let's take a look at that. So we're gonna call this like check shared edges. And let's see here. Check the number of, so that's share. Tri-mesh has a lot of functionality, but sometimes the way they implement certain things is kind of goofy. And I've gotten shot in the foot sometimes following or using their implementation. So I kind of like writing stuff myself, and usually it's easier than you think to do it. So check, well, actually we'll just say check for problems. Okay, so let's just bring this over here. Back to Iota. And, you know, actually, this could actually just be a straight up watertight check. And we've got our bad behavior here. So what we want to do is something like this. So what we're doing here is we'll just convert this guy to a tri-mesh right away. So my mesh format that I use is just a simple tuple of vertices and edges. Tri-mesh has way too much stuff attached to the mesh. I don't like it. So I don't want to use it. Generally, I don't need things to be cached. It doesn't matter. I don't want to have all this behavior on them. So So once we make our tri-mesh object, we can look at faces unique edges, which is a list of lists. Or actually, no, it's a NumPy array. No, it's jeez, I need to get this straight. What it is. So yeah, it is. This is unique edges. You know what? Maybe this isn't doing what I think it is. Faces unique edges. Okay, maybe this is going to be something that I have to work through here. It seemed to work. It seemed to be working before, but maybe I don't understand actually what this is doing. So it looks like for each face return which. Oh yeah, no, I do know what this is doing. Yeah, so this is just saying for each face, which of the unique edges build that face. So every face has 3 edges, right? But then what we don't want to see is we don't want to see one of those edges being shared by more than or less than a certain number of faces, right? So we have a dictionary called edge to faces, and that is going to hold that mapping, right? So we're going to build that mapping here. Now what we could do at this point, we could actually do some tests on it at this point. So holes, so like holes is going to be false, and what should we call it? I think they call it winding or something. And I'm not sure what that means, because I know there's the winding order of a mesh. Let's take a look at that is watertight again. See here, winding, whether every shared edge is, oh, okay, I see, that's where the winding is coming from. Yeah, I think we'll just call it bad edges. So, and then here at this point we don't care anymore about the actual edge index, right? This guy is like a unique index in unique edges to face index to a list of indexes. Okay, so if we've got less than 1, or if we got less than 2, right, that's a hole. Else if it's greater than 2, That's a bad edge. So we can say just return, actually, so just do not holes and not bad edges. Okay, so, and then just for now, since I don't have a better idea in mind, we can just print edges, holes. So let's see, would this have sniffed it out right away? And I think that, you know, there's gonna be other, actually, just check, just holes or bad edges. Yeah, because another condition of watertight, which I'm not gonna check, I don't want to write the check for myself, is like checking for intersecting faces. I could actually write that myself, but I don't want to. So instead of these other things, we're going to just run this new check on it. So diff.check holes or bad edges. Other stuff. And we'll just exit for now. Actually, you know what I could actually do is I could just return both of these things. I like that. Let's just do that. So that kind of forces us to think on the side that we're invoking this from what we want to do with the result. And I like that. So we can move this logic out, which is good. And it makes sense to do these things together because both of them require building this map of edges to faces, which is not, you know, it's not going to be super expensive for our situation, but it's not free. So we'll do holes, bad edges, equals this guy, and then we can do that test here. If holes or bad edges, that's nice, then we're not checking the inverse, but we're just checking if holes or bad edges, then we can print that the check failed. Check failed, holes. Bad edges, this, and then view it. And let's just exit right here just so we don't waste time. And then if this seems like it's working, I'm going to replace the that info function that we were using before with this, because I think this is going to be clear. Say check failed Holes, false. Oh, I need to add bad edges. So it doesn't have holes, which is the thing that was confusing to me. We don't have holes, but we are going to have bad edges. Yep, holes false, bad edges true. Okay. And let's just now let this check pass. And before, we were getting this kind of confusing message when it tried to do the diff, where we start seeing these components that, you know, it's confusing because they're obviously not there. We're seeing these components and boundaries. So diff, I think diff multiple parts is what I'm using here. Right, so we get the mesh is not watertight. Boundaries, and then we analyze view comps, which I just don't think is going to be necessary. I think we want to do like a new info, so we'll just call it info new on the mesh before we view it. We can deal with these other functions later. So what should info new be? We're going to actually grab some of this stuff here for info new. And open this in-ops group. So our current info function finds boundaries first, looks at boundary lengths, plots the boundaries. And that was getting called in the context of this analyze view comps. That's why we're getting that weird stuff going on. So I think I'm going to get rid of that function, but we're going to do something like this. So we're going to info mesh. We're going to do this check first. So we already know that we're not watertight at this point, so we don't need to check that again right at the moment. We don't have a name, so we can get rid of that. But we do have this holes or bad edges thing. And then we're also going to do the boundary check just on the raw thing. So we're going to do this. Print this info. Okay, so instead of showing watertight, we're going to show holes and bad edges. So this should give us enough information, and we're not going to reprocess or nonsense like that. this will be info. Okay. This was a different function. I'm going to just go ahead right away and let's see, am I invoking info anywhere else? And am I invoking this analyze view comps was just way more, yeah, this is just way more confusion than it was worth. And get rid of it. And info. You actually diff.info. I think. Nice. Okay. I think this is going to work a ton better. Okay. So we're not checking right away now, but will our error messages kind of show what's going on? So we're seeing mesh not watertight, spaces, no border loops, no holes, but bad edges. And I'm just gonna add a little bit of additional output here. So we'll just go like this. Then holes. T tight meshes should have 0 holes. Holes might be fixed with. I've been trying to do better error messages lately. Repair. I think it's repair. Try mesh.repair. Repair broken faces. Yeah, try mesh.fill holes. And then we'll just do another one. If bad edges, bad edges means that more than 2 faces are sharing edge. Let's see here. This repeatedly concat extra concatenations of the same structure. Followed by duplicate text removal. Okay, we'll return this. Okay, whoops. Let's see if this gives us and then I had some stuff here where I was actually, let me get rid of this plotting because I don't need that anymore. I was actually plotting the border loops, which might be a useful thing to do when I was... Okay, so what do we have? It's like vertices, bad edges means there are more than two faces. Yep. Okay, so that's giving us a nicer error message now. And yeah, okay, here's what I want to do. So I'm gonna take this plotting the boundaries and add it to our new info. So here, so if so we'll build this and loop for its list. Yeah, okay, cool. And I think we're gonna rename this to info old. Comment this out. Okay. And can give this a better name, like watertight info or something. Watertight info. Okay. Okay, so that wraps that up. And let's see here. Let's just make sure our other logic. Oh, jeez, this. Why did it not rename this? Okay, problem is true. Let me just make sure that this fails, and then we'll add the change back in and the fix back in and make sure that it doesn't fail anymore. Yep. Okay, cool. Okay. I'm playing music from White Bat Audio, and this particular piece really reminds me of kind of reminds me of Mona Lisa Overdrive from Matrix Reloaded. It's got that kind of like pitchy synth thing in it. I like it a lot. I've talked about this before, but I need to make a list of these songs so I can play just the good ones. Make a list of the ones I really like. Gosh, where was it here now? This part's new. And I should see some commented up. Here we go. All right. And diff is in XP, so I'm not gonna check that right now. Okay. There's so many Boolean operations now. This would be so slow if I wasn't using manifold. You can see like all of these little panel notches and stuff, and they're all individual operations. It's pretty incredible how well it works. All right, everything works now. Cool. So one thing that I'm going to have to address at some point is the fact that you get these shading errors on stuff when you use auto smoothing. So this needs to either have some more support here or not be auto shaded or have more triangles or something. I've got some ideas about how to fix that. I'm not too concerned about it now, but that's something that I gotta think about for the future. Another place that it shows up is on some of these cuts in these curved surfaces like this. So in order to fix these kind of like shading creases, a really easy solution would be is just to like add more loops. So if we clean up and limited dissolve by like 1 degree, so that turns all of the triangles. So now we don't have like the weird asymmetry. And then what we can do is we can just like add some more cuts like this. And that pretty much is gonna solve that. So it's just, I basically just need to do this. You can see it's just barely visible now, like right here. So I need to just do something like this programmatically as part of my process, and that'll solve that problem. And I think the way to do it will be, I can use like a Boolean to cut out the area around these features and then kind of concatenate them back in, and then remove interior geometry, so we are still left with manifold. Okay, so that takes care of that. So what I want to work on next is, I had done some work where I switched around the orientation of some of the component meshes that I'm making, and I'll show you what that looks like here. And I fixed it for a couple of the ships, but there's other ships that it hasn't been fixed for yet, so I need to do that. And I thought I could go through all of them. We could kind of look at each of the ships. There might be some issues, maybe we won't get to all of them, but we can get that fixed and kind of see the whole lineup and see, you know, if there are other issues outstanding. I've refactored and renamed some different things at this point, so it would be good to go through that stuff anyway. And let's see. So let me actually bring up my my list. So this is a list of all of the ships. So I'm just gonna kind of copy this over. So I think the needle is fixed because that's one that we're looking at right here. It's going to be a really simple fix because basically we're just going to be either having to add or remove a 90-degree rotation when we're adding some of these parts. Might be a challenge to figure out which it needs, but should be fairly straightforward. And some of these ships don't actually have some of these devices added, so it will obviously there won't be anything to do. Okay, so let's open up our, let's close all of this. And we were just looking at the high detail version of a model, but we have low detail versions as well, which is what the game uses, and we're going to be doing the work in there because it should, you know, it'll generalize the high detail version. Okay, so let's start with one that we know is going to be working. And I'm doing this logic where I'm adding like another ship on below. We don't need that. So, and this should be pretty quick to go through everything. Okay. Whoops. Okay, yep, okay, so here's the needle and you can see the problem. These sensors are off by 90 degrees. So let's jump in and fix that. Okay. See, like this is, it's just a matter of moving the right thing. So we have top, bottom, front. So so basically top is going to be I. I is a shorthand. I guess it's not shorthand, but it's the function to create an identity matrix, which basically means no rotation. So top, bottom is going to be 180 around X, and front is going to be 90. Let's see if that fixes it. And then we'll just check the high detail version as well. Top, bottom, front. Okay, interesting problem here. We've got faces reversed on those sensors, so let's try to fix that too. Okay, and that's backwards, so this needs to be yeah. Okay, cool. Let's see what's going on with that sensor. So it looks like our low sensor lens needs to be reversed. So we're going now from negative to positive. Start. Okay, yeah, I'm not sure what brought that issue on exactly. I was refactoring some of this, but I suppose I could have just flipped something around. Okay, but that seems to be taken care of. And I'm just going to check sensors high. Typically these high detail versions sensors high is just oh yeah, that's that additional, those additional greebles. I don't think we're using that anymore. Okay, so the needle is done. Let's check that off of our list here. Actually, I will just copy this list into here so we can all see it. Okay, let's just double check this guy. I think he should be good to go. And let's just, we don't even have to worry about some of this. So yep, he looks good. Okay. Yep. Here, we're all out of whack. So the only thing makes this complicated, right, is that sometimes I have the sensors sort of aiming a certain direction, either by rotational offset or just the direction that a normal of, or either the direction a normal or an intersecting ray is facing, and sometimes I have them sort of hard coded to be facing a certain section, like they might be stuck onto a facet that isn't facing forward, but I want them facing forward, right? So let's take a look here. I'm shooting a bunch of rays, and I'm just pre-rotating a X90 rotation. So I think if I get rid of that, I think that should be all that we need. And if it is, okay, that's it for the side ones, but not for the front. Interesting. Sensor long A. Oh, yeah. See, we can get rid of this crap. And this can actually be simplified once I get it working. Yep. So that looks like how I want it to. Okay, now we can get rid of this. Simplify. And this, we can get rid of this extra parentheses. It's fun when things get simpler. Okay, so that fixes the owl. Let's take a look at the flesh. I know this one's going to need it. Let's see if we can preemptively fix this one. Okay. I'm not going to try to preemptively fix it. But I think... What do we have? Actually, no. Top, bottom, left, right. I should be able to figure this out. Top, bottom, left, right. So top should just be identity. Actually, you know what? Why am I doing I? I should have identity in there, right? Sometimes I just don't have obvious things that I should have. Okay, so here we're gonna do x 180. Can I get these directions right? Actually, left and right are the forward-facing ones, so they should also be. Let's see here, x -90. Okay. And this nonsense we can get rid of. Long. And these extra parentheses kind of saves some lines of code too. Okay. Ship it. All right. Cross that one off the list. Our new fighter that we made the other day, that is probably not going to be a fighter, but it's going to be a shuttle. This should be an easy fix as well. What are all these sensors? A lot of sensors here. Derp. Okay, so I think these are the forward-facing ones, right? And so first of all, we'll get rid of that. The forward-facing ones are going to be x -90. These top ones don't need it, and this back one shouldn't need it. So I think that does it. And actually, whoops. This back one I'm gonna, yeah. So this back one we can hard code as a rotation x90, because we know it's facing exactly backwards. Yep. Okay, that takes care of that one. Okay, now we're on to some big ships. So I think this IOTA should be working fine because we were just working on the high detail version of that. There's one other thing that we that I want to fix with this IOTA, which is the markings are kind of in a separate spot, and I want to just generate those with the ship. But this all looks good. You can see the window markings. So we already have some markings being used. Okay, so now we have big ships, Dirac, Hammond Newton, and Ashinoko. I think the Dirac, I don't know if I got as far as putting sensors on the Dirac, but just for kicks and giggles, let's run it because there could be other stuff that's broken in it. Nope. Oh, actually, there's something. Let's fix these fins. So these fins have some bad faces. The radiator fins. Radiators. Rad. This is so goofy the way this is written. Flip. Let's get rid of this flip. See if that fixes that. Yep. It's kind of fun when problems are easy. Feels very productive. This is another one of the white bad audio pieces that I like. Okay. Hammond, I haven't touched this guy for a while. I bet he might be broken in a couple different places. I don't even have it imported here. Yep, we're all wonky here. Oh, that's not good. I'm generating the high detail, radar, which I definitely don't want to do. So we got to fix that. Wait a second. I think. Yeah, okay, that's a problem with the radar, not with the function. So the radar is greater than equal to 0. See if that fixes that. Yeah, that's better. Okay. Sensors. I think this one is going to be a quick one because I think these are mostly Oop. See, we can just add those markings back in. Okay. Just a couple left. And then we'll be done with this. See, it was kind of a most devices and things I have oriented in a coordinate system where where like Z is coming off the surface. And for whatever reason, I think it's because some of the first sensors that I did were kind of like these long things that would like face forward. I have all the sensors aligned with their direction down the axis of the center being Y, and that just made everything more complicated. Something that I've realized is that sometimes I try to get too clever with the coordinate systems of these different parts, and if you're going to do this stuff programmatically, I think it's important not to think too logically about it, but just think about like the part should have whatever coordinate system makes it easy to do the programmatic modeling. Because you could always go and even programmatically adjust and change the coordinate systems of these 3D parts in the hierarchies later. So, and I don't think I don't even have sensors on the Newton, so, but let's see if there are other problems to fix. Nope. Okay, and actually we've got a couple more ships in this. We have the yachts, but I don't think any of those have. I don't think any of those have sensors either. Oh, and our 2 freighters as well. Hey, those. Yeah, I don't think. Yeah, I don't think any of these ships. Maybe Yacht A has. Maybe Yacht A, so we'll check that one, but I kind of doubt it. Okay. Ashinoko. Sorry, got a little distracted there. Go. Ashinoko. And let's just preemptively look at it. Sensors. I think this is going to be another easy one. Yeah. Boop. Oh, actually, this is one that I think I didn't fix. This one actually might not be working, so this might be something interesting to do here. Okay, so let's just exit here, because what we want is, and this is good because this will kind of show you what the issue is. Yeah, okay, so this is already broken because I changed the orientation of that lens, but what we want is we want it to face up. So the base, we can get rid of this. Yep, okay. Now, I think all we have to do is get rid of this, and then we're good to go. See, it's like a simplifying thing. Sensors, parents, anything. Fuselage radars. I think all of that's still gonna be good. Yep, look at there. Man, I'm really proud of this ship. This is the newest, or one of the newer designs, and I just really like it. Something I need to work on a little bit more is the proportions. My ships look a little bit rear heavy sometimes, but I like this one a lot. doing for... Yeah, we're good. Okay. And I think... Let's just check the yacht, but I think... Actually, I think it's just yacht. Let's check it, but I don't think it has sensors. Whoops. A. Whoops. Expected. Old one that doesn't even have extra data. Yeah, there's no sensors or anything on this, so we're good. Okay, let's now that that's done, actually let's fix the Cyota. So the Cyota has markings that are stored in a separate spot, and I want to get those into it properly. So it's actually this, and yeah, so this, we're gonna take this guy out of here. This really shouldn't be called livery, it should be called markings, because livery's another... We'll leave all this viewing stuff on just to make sure that it's all still working. Let's see, first geolivery. So we're just making this stripe. We've got a mesh, and then I'm saving it to a part called marking 0 here, which we basically just need to add that in to the tree. So we'll just return it, and it needs to be something called marking 0. So something like here. This needs to be cleaned up. Okay. Markings equals markings parts, and I think we are only using the fuselage actually, so I think it can go in here. We'll see. And we can just say parts. This is kind of hacky, but markings 0 equals ps.part parent fuselage model markings. And let me just check the YAML. So this is what defines how this model goes into the game. And we should already be excluding markings 0. Okay, yeah, see, this is, we need to exclude. Yeah, we'll still call it marking 0. We'll exclude it here. And then change this to be this will be our original one here. I don't think we need a name. Part Scioto marking 0. Okay. I think that's all we actually need. I don't know why this is complaining. Oh, it's not returning anything. Return outside of, oh. Okay. Okay. I think that will fix the Scioto. We'll definitely test it here. We'll make sure that it's working before we go on. Oh, I know what's going on. Okay, there's like some offsets and stuff that happen, so we actually need to do this later. So just to be safe, because I don't want to ding around with this right now, we'll do it at the tail end. And I think that should take care of it. Yeah, there we go. Okay. All right, and I'm just gonna check in our ship viewer right away if Scioto is loading correctly. Yep. Okay, now our markings are not working properly. Why is that? There isn't another property in here somewhere, is there? Oh, I've got to add an auto smooth angle. I don't think that would do it, but unless there's, yeah, but there's other markings that I have. So let's see. Slice markings. Okay, yeah, there's a marking property in there too. That's what I was missing. Okay, so markings, oops. I wonder if I need that marking thing in the model info if it's in the part. This is marking, right? It's true. You know what? need to regenerate it, that's why. We'll drill into why the, whoops. We'll drill into why the why that sort of like redundant marking stuff is required some other time. Did I do the spire? Nope, I didn't do the spire. Okay, one last one, and then we'll be done here. Yeah, look at that. Oh man. Okay. I have a feeling that this is going to be a really easy one as well. Parts, decals, angle. X-root. Yeah, it's just getting rid of this thing. And then we got to add a All right, that looks good. Ship it. And I will clean up these extra visualizations later. Okay. So we've got the spire. We've got the needle. Got a couple of needle variants. Little flesh variants. Third can. The owl, I'm just checking the sensors and any other stuff that might be out of place here, but it's looking good. Newton didn't really have any. Ashinoko stuff generally looks oriented correctly. Cruiser. Yeah, the cruiser isn't exporting right now. That's okay. And none of this stuff has sensors yet. Okay, and let's just check in the scenario viewer just to see if everything, whoops, if everything is loading correctly. Oh, interesting. Okay. Just gotta copy something in somewhere quick here. There's a correct way to fix this, but I'm not going to do it right now. Just want to get this up and running. Modeling projects. Models. All right, there's everything. Everything is looking good. This process kind of goes through the game data file path so that the ships have weapons and stuff on their hard points. It's nice to test that and make sure everything's working. I need to build some either different functionality or remember what I did, because we were trying to build this fighter last time, and see, these hard points are just sort of aligned like this. They should be tilted so they go with the shape here. That's a project for another day. Edward Ferrari says, hey, nice to see you back. I'm just listening in the background. I'm doing some homework. Nice. Well, I'm almost wrapped up for tonight, but you can go back and listen to the stream from the beginning. I had a busy week last week, so I didn't get a chance to stream. But I'm hoping to get back into it and do some more. We're going on vacation this weekend, so I probably won't get to much more before next week. But when I do, there's a lot of interesting stuff to work on, and got some cool stuff coming up that I'm pretty excited. I think we're getting to a point where I'm gonna dip into some rendering stuff, because the high detail ships are looking really good at this point, I think. And maybe back to some game stuff. And then a new project that I'm going to be working on is actually workflow for getting some of these models ready to 3D print. And I want to build functionality for cleaning things up, getting ready to print, separating out certain parts. And then the big missing piece is building connectors. So building things where if I know that I'm gonna have to print a part separately, how I can, like, sort of with some degree of automation, make a nice connecting piece that I can attach together. So yeah. Yep. Oh, thanks for the well wishes about the vacation. Yeah, you know, the fun thing about doing this is it doesn't necessarily take a lot of time. But what happened to me because I work on my project anyway, right? What happened to me last week is I was just busy with work and other random things going on. So by the time I would get to my project every night, it was like late. And in the past, I haven't had the best viewership when I start streaming, you know, at 11 or midnight. So I try to start at a decent time. I can never get started before about 9:30, 9:45. It seems like that's something I want to work towards, though, is getting started earlier. So, all right. Well, here's the result. We cleaned up some stuff. We've got some new tools for kind of checking and making sure that our meshes are going to play nice with the Boolean operations, and it's pretty productive time. So thanks everybody who tuned in. Thanks for hanging out, Doug. Thanks for hanging out, Edward, and sorry that I am ending just as you're joining, but go back and watch the stream, get me some watch hours post upload or post publish or whatever the terminology is. And you guys have a good night.